So you don't have a favourite actor from the X-Men films, Sarah?
Well, so this is probably going to, like, the two that I can think of that I remember the most, and I think this is very indicative of the age I was when I went to see the movies, is Cyclops and Wolverine.
Okay. Yep. I mean, that's,
I'm getting claps from Zach. That's good.
That's the OG.
But like, I can't really remember any of the female ones.
Well,
like none of them stood out to me.
I would normally opt for also Hugh Jackman as Wolverine or Ian McKellen as Magneto. I've got a big soft spot for Ian McKellen because he's Gandalf as well.
Actually, yes. No, he was a really good character.
And he's really good. He makes you root for the bad guy, which is, what all good villain casting should do.
Absolutely.
But today, I think our favourite X-Men has to be, or X-Men actor has to be the one and only Halle Berry. Do you know why?
Oh, she was Storm. She was Storm.
And we are going to summon up a storm because today's episode is all about strong winds, destructive weather, and the biggest beast of them all, tropical cyclones.
Oh, fun. All right, I need to go and check on my furniture.
All right, let's get into it.
My name's Sarah Perkins Kirkpatrick, and I'm a Professor of Climate Science at the Australian National University in Canberra.
I'm Ian Strachan, a former journalist turned science communicator. We're members of the Australian Research Council Centre of Excellence for the Weather of the 21st Century.
And this is Totally Cooked, the climate and weather podcast.
Slick.
Cool.
One take, done.
Can say it in my sleep.
Yeah, except when I swap it around.
Oh, that's right. Yeah, you took my line last week.
It felt good. Felt taking the power back. Okay. In this episode, we are talking about all things storms and cyclones, also known as hurricanes and typhoons, depending on where you are in the world. We'll be answering questions like, what are storms? What are cyclones? How is climate change affecting them? And what, if anything, can we do about it?
Okay, so let's introduce our first guest. Well, sorry, not our first guest, our only
guest. No, that's true, though. It is our first guest for today. Our first and our last.
Our one and only. Let's introduce our guest for today, Professor Liz Ritchie of 21st Century Weather and Monash University. A professor of atmospheric science, Liz is a leading expert on tropical cyclones here and around the world, and we're delighted to have her with us. Welcome, Liz.
Thanks for having me, Sarah.
We're in the weird situation of looking at our script with our guest, and it says here, afford time for Liz to respond.
I know, and because I was looking at Sarah, I said, thank you, Sarah, instead of thank you, Sarah.
That's okay.
That's
Ian.
fine. That's totally fine.
Supernatural, chill.
Yeah. Zach will make this sound like it just flowed perfectly and we didn't pause for anything.
So storms. So you're using terminology, that is.
Well, that's interesting. So that you're here to clear this up for us, and
okay. Part the clouds.
Yeah.
Part the clouds.
Illuminate us. How would you define a storm?
It's a thunderstorm.
A thunderstorm is a thunderstorm? Mm-hmm. Always.
Yep.
Okay.
Now, there are some tropical cyclones that get cold tropical storms at a certain intensity level.
Okay.
But yeah, if you talk about a storm, you're talking about a thunderstorm.
Right. And a thunderstorm is, how does a thunderstorm happen?
How does a thunderstorm happen? Are we recording right now?
Yeah, we're on. This is super general. The audience for this is people who have never actually stopped to think what a thunderstorm is or how it happened. And believe it or not, I was lying in bed a few months ago on a very humid Sunday when there was thunder outside, and I was lying there thinking, what is thunder?
I get asked this question every time there's a thunderstorm. My kids ask this question, like, "What's the thunder?" And I'm like, "Oh, I don't like." I automatically want to say it's God making a noise upstairs because that's what was said to me as a kid, even though I know it is not correct.
They're playing 10-pin bowling for me up in the clouds.
Oh yeah. Oh, God is angry. I think my parents wanted to instill fear into me.
So how does a thunderstorm happen?
So a thunderstorm can happen anywhere. It can happen over the ocean or over the land, and it happens when you have very warm, moist air rising up into the atmosphere, and that air condenses and starts to form a cloud, and that's what you see. You see these little condensed water droplets that make up a cloud, billions and billions of them. And if that cloud continues to grow quite tall, then we start to get up into the atmosphere where it's below freezing. And so instead of just cloud droplets, we have ice forming as well in that cloud. And once that cloud gets tall enough, reaches all the way up to the top of the atmosphere, then you start to get electrical charge forming within the cloud due to breakage between little ice crystals that are banging off each other, basically. And that charge separates so that you end up with a positive charge high up in the atmosphere and a negative charge at the base of the atmosphere where the larger, heavier ice crystals fall to. That negative charge at the bottom of the cloud then actually triggers a response at the ground, which is a positive charge that builds up at the ground, and it builds up in trees and other tall objects on the ground. And eventually you get enough discontinuity between that positive and that negative charge that it discharges as lightning. That lightning then instantaneously heats up the atmosphere to 30,000 degrees centigrade. And the sound wave that is created by that instantaneous massive expansion of air because of this heating of the air is what is thunder. And so once we have that lightning and that thunder, we have a thunderstorm.
I didn't realise it got that hot with lightning.
Yeah, absolutely.
So
yeah, it basically just it plasmarizes the air.
You did say 30,000 degrees, is that
30,000 degrees centigrade. Yeah.
How did they measure that it was that hot?
They use different devices. You know, they're doing a lot of experiments now where they will trigger lightning. In fact, it's not sitting here. I've got a rocket sitting at home that's a sort of rocket they fire up into thunderstorms with a wire attached to it to try and trigger lightning. And then they have various different instruments at different wavelengths that measure the electromagnetic information that's coming off that discharge. And from that, they can back out things like the temperature and the structure and from all the microwaves and X-rays that are being actually given off by because the hotter something is, the higher energy electromagnetic wave it will send off, and they can measure that.
That's incredible. I had no idea it got that hot. And so that's sort of like plasmarization of the atmosphere. I don't even know if that's a word.
Yeah.
How long does that, it's a split second, but how long does it take for the air to kind of get back to its normal state after that?
So you have this vacuum. So you massively expand this air, and then the air just rushes back in to fill that again. So it's instantaneous.
Yeah, wow, God.
And did you say you have a lightning rocket at home?
I do.
Yes, I know.
Yeah.
Can we look at that a
Can
bit
we go
more,
back
please?
to that, please?
I can bring that in, and we can get some pictures of it if you like. I had it sitting in my office over in the other building, but I couldn't bring it over here with me, so I took it home.
We need a picture for the show notes.
Yeah, absolutely. Yeah, the people at my one of my previous jobs at University of Arizona are actually some of the biggest, primary investigators understanding how lightning works. And so they'd go down to Florida every year and do these rocket measurements, and they gave me one of their used rockets
That's
as
incredible.
a souvenir. In fact, one of the guys, Phil Kreider, is the person who invented and built the original lightning detection network devices for Vaisala.
What's Vaisala?
Vaisala is a company that makes meteorological instrumentation.
Oh, they sponsor the Australian Meteorological and Oceanographic Conference almost every year.
That's right. They make standard weather observing instruments, your temperature, your wind, your rain gauges in your Stevenson boxes, and they make lightning detection network devices and many other devices as well.
Do the lightning making rockets always work?
If there is a charge separation in a thunderstorm, then they will work. Yeah. It will attract the lightning discharge to the wire that's attached to the rocket.
Amazing.
Yeah.
So, Sarah, next time your kids ask, what is a thunderstorm, you can say it's the sky exploding.
Yeah, pretty much. I think that will frighten my middle child.
There's nothing to worry about. It's just the sky exploding at 30,000 degrees.
Yeah, nothing at all. It'll just vaporize you in a split second, but that's okay.
Yeah.
My mother-in-law, they've bought a property that they're renovating, and they have a lightning rod sitting on top of the building, and it recently got struck, and they were in awe watching that happen. So maybe instead of getting a rocket, we might just stick a lightning rod somewhere close by and watch what happens.
How does your dog go in the lightning, Sarah?
She's a scaredy cat, doesn't like it at all. Will find something to hide under and stay put until it's over. I think that's pretty classic.
So that's a thunderstorm, which, as you've made clear, is very different from a wind storm.
Well, the basic difference is that a tropical cyclone is a windstorm. It's a vortex of wind, but it is actually made up of many, 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 many thunderstorms. So it's a much bigger entity that's a conglomeration, if you like, of thunderstorms, where you have the most intense thunderstorms and the most intense winds close to the centre of the cyclone. And then as you move away from that centre of the cyclone, the thunderstorms will be more sporadically spaced in spiral bands, and they'll be weaker.
So a cyclone is a bunch of exploding sky glued together.
Yeah, in an organisation that we recognise as, sort of a pinwheel organisation.
So is it right to say that like a thunderstorm is just a thunderstorm is usually quite localised, but a tropical cyclone or hurricane or typhoon is, generally speaking, a bigger system and also has different processes that aid in developing it?
Yeah, that's correct.
Okay.
So a thunderstorm itself might only cover a few kilometres
Yeah.
Or it can organise into a bigger system with maybe several thunderstorms embedded that's 100 kilometres across. But your typical tropical cyclone is going to be 500 to 1,000 kilometres in diameter. And because it organises itself with a wind system associated with it, that actually acts to organise how the thunderstorms are organised in the cyclone. So you end up with winds that are converging into the centre of the cyclone, and those winds bring that moist, hot, humid air that we're talking about is necessary for a thunderstorm into the centre of the cyclone. That air is now very unstable, so it rises up in and forms thunderstorms at the centre of the cyclone. The cyclone is rotating, so those thunderstorms form as rotating systems around the eye of the cyclone. So you get this organisation of those thunderstorms because of the wind system associated with the cyclone. But the overall size of the cyclone itself is much bigger and made up of hundreds of thunderstorms.
That's incredible. I never thought of a cyclone like that. Lots of different devastating storms all at once.
It is. That's why you can make the argument when a few years ago, I should say, probably back in about 2019, Donald Trump suggested nuking a cyclone that was approaching the US mainland. The immediate answer is not worth it, except for that it will actually cause a lot more damage than it would actually change the course of a hurricane, because that's just going to absorb all that energy.
Yeah, right. Well, so it would have enhanced it, not destroyed it.
It wouldn't have enhanced the hurricane. It just would have put a whole lot of really nasty stuff into the atmosphere.
Right. Okay.
Yeah.
Well, I'm glad that didn't come to fruition.
A little bit. Hopefully he doesn't have the idea again today.
Oh, yeah.
And let's not include that in the podcast.
No,
that little
I'm already
video.
thinking that I want Zach to do a little TikTok of Trump nuking a cyclone, and then seeing what kind of graphics and memes we can get out of that.
I'm sure it's possible.
Yeah, I wrote a conversation article on that at the time, kind of
Yeah.
refuting the idea. Yeah.
Well, yeah. Let's hope no one has the idea to nuke a cyclone or hurricane again anytime soon.
It's very
Forever.
much it's just like something out of a movie, though, isn't it? Like in Hollywood, the US president, or more to the point, the hawkish, Secretary of Defense always wants to nuke something. Like in Independence Day, they want to nuke the aliens, and or Armageddon, they want to nuke the meteoroids. So why not nuke a cyclone?
Why not?
Why not?
It might just kill more people. But yeah, let's put that to one side.
Liz, you mentioned that you were was it at the University of Arizona once upon a time? Can you tell us, maybe going even back further than that, how did you get into storms and cyclones? What's the story there? When did you first get curious about these things?
That's actually an interesting story. It's a little bit different to the standard stories. We've just been seeing a lot of stories being posted on a tropical storms bulletin board from ex-NOAA employees about their experience that got them into studying hurricanes. And most stories are about, as a child, you experience one. So in my case, that didn't happen. In my case, I went through school and university, and I knew I wanted to be a scientist. When I went to university, I did maths and actually chemistry for a while. Ended up sort of funneling myself into maths and statistics for my undergraduate. And somewhere in there around my end of my third year, I did a summer program at the Bureau of Meteorology. And that got me in touch with one of the researchers in the Bureau of Meteorology Research Centre, who used to be a forecaster at Darwin. And he was a forecaster when Tropical Cyclone Tracy hit Darwin in 1974.
Was that Greg Holland?
That was Greg Holland.
Yep. Okay.
So I worked with him and eventually came back after I finished my undergraduate, went into defence for a little bit, didn't like that, left and went to work for him at the Bureau.
Were they trying to nuke the cyclones in defence? Is that why you left?
They weren't. They were just a little bit old-fashioned for my taste. Yeah.
Sarah's got her own Army University experience.
Yeah. Oh, yeah. Well, Liz and I used to work at UNSW Canberra at the same time.
That's right. Yeah.
Yeah, I didn't last very long either.
Yeah, and so I went back to work for him while I was thinking about, I knew I wanted to do a PhD, but I didn't really have any focus for a PhD. So I went back to work for him, and along the way, he sent me to a field experiment that was running out of Guam. This was a big international effort. Australians, the US, even the Russians and the Chinese were involved in different ways to try and understand how tropical cyclones move. Because back then, this was back in the late 1980s, early 1990s.
When we were all getting along.
When we were all getting
Briefly.
along.
Very
briefly. It was a
briefly.
lovely period of time.
About the 10 years that it was, yeah.
And we didn't even have really good fundamental understanding or theoretical knowledge of how tropical cyclones moved. let alone anything else that we worry about these days. And so this was a big 5-year program that had been funded by the US Office of Naval Research, at the end of which we went out and did this field experiment after they'd developed all these theories about why tropical cyclones moved. And the field experiment was designed to try and test these theories. So I went as a little gopher, had the opportunity, and I was maintaining some computer systems for Greg while I was there, but I got the opportunity to fly through a super typhoon on the NASA DC-8.
Wow.
There was Super Typhoon Flo. It was one of the strongest super typhoons ever recorded in a research flight in the Western North Pacific, and it was amazing. It was just amazing.
Was it frightening as well?
I wasn't frightened. I didn't know enough to be frightened, I guess.
Okay.
But they also, NASA hadn't, this was the first time they'd flown into a tropical cyclone in decades. They just hadn't done it, probably since back in the 1960s when they were doing Storm Fury in the US. And so they insist on flying at quite a high level. We were up at about 30,000 feet, so 10,000 metres or so in the atmosphere, right near the top. But this thing was a super typhoon at the time, so it had all the classic features and structure, and I got to see all that. And it was just amazing. It was beautiful. We broke out of the cloud into the eye, and you could see all the way down to the surface. You could see the stadium sort of sloping out structure of the eye wall. Yeah, it was just amazing. And I was on board with a bunch of weather geeks as well, so that helps too. People who actually understood what we were looking at and what we were doing and could explain it to me. So yeah, that kind of set me on my course.
That sounds like an incredible experience.
It was amazing.
What was it like in the plane before you broke through into the eye wall? Were you being buffeted around? Did it feel like being in really strong turbulence? What's the experience like of being on a flight like that?
Yeah, so that one, because we were quite high up, there was certainly turbulence. There were some quite strong thunderstorms in there, but it was really just shaking and shuddering, the sort of thing that you often experience in a commercial airline flight. So there was nothing too major that we flew through when we were that high up in the atmosphere. I've been on other flights where it was a little bit rougher than that.
Yeah, right.
But, yeah.
That's wow. So that was it. Were you sold from that point that that's what you were going to do a PhD on?
Yeah, pretty much. I landed that night. Greg hadn't been on the flight, so he met me when I got off the flight that night, and we spent about 6 hours talking about what I was going to do my PhD on.
Awesome.
Yeah.
That's so cool.
And that was it, yeah.
Got radicalized. Are those planes at risk of being struck by lightning when they're flying through cyclones? How do they mitigate that risk?
Well, the plane itself is kind of a Faraday cage.
Okay.
So when it does get electrified, it can itself. And so you can see like St. Elmo's fire sparking off the wings. I've seen that before on the wingtips and off the nose of the plane.
What does that look like for people listening at home who haven't been in a plane in a hurricane?
I'm not even sure what that means.
You can see a couple of different discharges. One of them is just kind of like a green aura, almost like an aurora, I feel like, just coming off the nose of the plane or the wingtips of the plane. And otherwise, you can actually just see little spark discharges coming off the wing of the plane if it charges up enough. And then if it gets struck, the lightning just kind of goes around the plane and then dissipates.
Wow.
I'm not sure if we need it, but perhaps could you explain what a Faraday cage is? Because I'm not sure if everyone listening to this might know.
It's a metal structure it's basically designed so that if it gets hit by something like lightning, the lightning it won't get inside of it. It will just discharge around the outside of it. So your car, for example, is a pretty good Faraday cage. And if it gets struck by lightning, the lightning will actually run around the outside of the car and then it'll go to ground. So if you're in a lightning storm, in your car, stay in your car. It's probably the best advice. It's better than actually getting out and trying to run for shelter.
Cool.
And it's named for, is it Michael Faraday?
I think so.
The Royal Institution experimenter. I think this is someone who used to do a lot of public experiments in the 19th century in London relating to electricity.
There's one at Questacon, the Science Museum here in Canberra, that I remember as a kid, they would put it would be this amazing lightning show for a couple of minutes. And now it's just one discharge and that's it. So there must have been some sort of OH&S thing that came in. But anyway, it is in this massive Faraday cage. So no one will obviously get hurt.
Good way to get rid of your kids for a couple of hours, isn't it, Sarah? Leave them in the Faraday cage.
You shove them in the Faraday cage and they come out crisp. No, I'm not that. I'll just say I'm not that kind of parent.
That's exactly what that kind of parent would say at this point, though, isn't it?
We've already mentioned them briefly, but we're going to be taking a close look at the different types of cyclones in this episode. Liz, can you tell us what a cyclone is, please?
Okay, so a tropical cyclone is a wind vortex that forms in tropical regions, and that wind vortex has, it has cyclonically rotating winds, that's what a vortex is, but associated with that, and just because of atmospheric processes, that vortex develops a cloud structure that's quite distinctive. So if we're looking at satellite imagery like we do when the media are presenting information on a tropical cyclone that's out there at the time, you see a very distinctive cloud structure that is organised by that swirling wind.
And a vortex people can think of as rotation, like it's going round and round in a circle, you know?
Correct.
We don't want to assume too much knowledge here. I feel like everyone has seen a hurricane or a cyclone on the news, but I think it's important just to clarify what we mean by vortex.
Yeah, so a vortex is a rotating motion, if you like. It can be in water or it can be in the air. So if you take your cup of tea and you put your spoon in there and you stir it around, you create a vortex. And that's probably one of the simplest sort of visual explanations of a vortex.
Is it the same thing as when you're draining a bath and the whirlpool forms above the...
That's right.
Yeah.
Makes that
so that's also a vortex.
sound.
Yeah.
And then like at the very end, it makes a scary noise that
It
cats
does.
and children
That
run away
frightens
from.
my children.
Cats, children's and Ian's.
Actually, oh gosh, I don't know if I should admit this, but I will anyway. Like that's what I usually use to get them out of the bath is like, I'm going to take the plug out. The plug's coming out. I don't ever say you're going to
You
get
don't say that their
down.
toe's going to get sucked down or anything like that.
But that's enough because they don't like the noise and they jump out pretty quickly.
Zach, I feel like based on this parenting style that's coming through in this episode, we're lucky not to be working under this reign of terror.
You're a freak, Sarah.
No. Well, maybe a little. So Liz,
Sure.
what are the ingredients of a tropical cyclone? What do they need to form and what are the stages of a cyclone forming?
Okay, so a tropical cyclone needs an environment that's conducive for it to form, that's positive for it to inform.
Don't we all?
Don't we all? And so that environment is provided in tropical regions. You need nice, warm ocean temperatures. You need lots of moisture in the atmosphere, so high humidity like we find in tropical regions. You need warm temperatures. And then you need some atmospheric circulations or wind systems, large-scale wind systems, that kind of provide a parent circulation for a tropical cyclone to then form within. And we tend to, around the Australian region, get those large-scale circulations from the monsoon. So when the monsoon comes in, these large-scale rotating cyclonic circulations are part of that monsoon system, and they provide a kind of, if you like, parent system for a tropical cyclone to form within. So then for a tropical cyclone to actually form, it's got these conditions, and these conditions are the kinds of conditions that allow thunderstorms to form. All right, so you've got that instability because of the warm, moist air. The warm oceans provide a lot of that moisture to the air. So the first thing that you see happen is you see a group of thunderstorms forming within one of these kind of large parent circulations. And that group of thunderstorms might look kind of disorganized because they're just randomly forming because there's pockets of unstable air. But one of the things that the thunderstorms do is that once you have that rising air in the thunderstorms, because the thunderstorms only exist because air has risen and condensed into these clouds, that then pulls air from the surface into that region. So horizontal air then gets pulled into where those thunderstorms have formed because you've got this air rising, something has to replace it, and so that air comes in from outside along the surface. As that air comes in to what is now a very, very weak low pressure system below these thunderstorms, it starts to rotate. And it starts to rotate because of this thing called the Coriolis force. And the Coriolis force is that thing that happens because we have a rotating Earth. So we have, so the Earth rotates and that causes this extra rotation to occur in air as it moves over long distances. And in this case, we've got this air moving over quite long distances into where these thunderstorms are. So that air starts to rotate, which means you now start to get a vortex forming at the surface that's on the scale now of a tropical cyclone or this cluster of thunderstorms, rather than on the much larger parent system. And so that then it starts to actually organise those thunderstorms into more of a circular system. Thunderstorms get invigorated by this new air being brought in, so they get stronger. They get stronger, vertical motion gets stronger, more air gets pulled in, and now you start to get a system that's actually quite self-sustaining because the stronger the thunderstorms are, the more air they pull in, the more air they pull in, the stronger they get.
The early stages of a cyclone forming sounds to me like a group of teenage boys getting together with too much time on their hands, you know?
Loitering.
They're disorganized, they're loitering around each other, there's a lot of hot air going on, and then before you know it, they develop enough momentum to be self-sustaining and quite destructive.
That's that's a pretty good analogy. And it's a bit stochastic too. So they could be randomly getting together around a skateboard park or, over by the local milk bar.
Or the Westfield.
Or the
Westfield. Yeah, good old Westfield. So is it true that cyclones don't form close to the equator because they need that spinning effect?
That's correct. So they typically form about at least 5 degrees off the equator. And that's right, because Coriolis is 0 on the equator. It's kind of amusing because we actually do have what they call eddies on the equator. And these are still systems that they will rotate. But because they're on the equator, we tend to say they don't have a sense of rotation, even though they're actually rotating. So we call them eddies. And then once they move off the equator, then we give them either a cyclonic or a clockwise or an anti-clockwise sense that's going to be either a cyclonic sense or an anticyclonic or high pressure system sense.
So they're still, I'm trying to picture that. So they still have some sort of rotation, but they're not.
They're eddies.
Lock it in, eddies.
Eddies. That might have been a bit much, but
it's
yes.
a deep cut for the international listeners.
Yeah.
I have dreams now of this episode being clipped up into TikToks where Zach liberally sprinkles through little GIFs from The Simpsons where Bart wants to know about the Coriolis effect. He loses a toothpaste race with Lisa in the sink, and so he calls Australia to see if their water's turning the other way.
Yeah, that one wasn't that a toilet flushing?
The toilet. First of all, it was a bathroom products race in the sink, and then the toilet flushing. And when they got to the US Embassy in Australia, Bart asks, do your toilets flush the wrong way? And he's like, no, we installed a device to make them flush the correct American way.
And then isn't like Homer singing like their national anthem as he flushes the toilet?
Yes, Sweet Land of Liberty.
That's right. I've lost count how many times you've referred to that episode.
That's one of my favourites because it's so deranged. It's like the writers sat down together and probably got takeaway and decided how can they depict Australia as unreasonably as possible, as unfairly and unrealistically as they could.
I don't know. I think the problem with that is a lot of internationals might have thought that was how we are here.
We can leave them to their illusions until they come and have them dissuaded.
True.
Does anyone know why or like where we get the term cyclone from? Sarah? Have you read this bit? Is this being sprung on you?
This is why I've gone blank. Don't look.
I want to do those things where I send you something for you to read.
Cyclone is derived from the Greek word cyclos, meaning the coils of a snake. It was coined by Henry Peddington because the tropical storms in the Bay of Bengal and the Arabian Sea appear like coiled serpents of the sea.
So says Zach in his show notes.
I did not know that.
Well,
it makes total sense, right? Now, like it's got a Greek, meaning. But yeah, I didn't realise it came from snakes as well.
Got another one from Zach, which I will read out. Centuries ago, European explorers learned the indigenous word huracan, signifying evil spirits and weather gods, to describe the storms that battered their ships in the Caribbean. So
there you go.
How about
that one I did know.
Verified by the expert, live.
Okay, so let's look at the different types of cyclones that can exist. So we've got tropical, subtropical, and extratropical. What's the difference between the three? We hear a lot about them in Australia when they're doing the weather forecast, but I don't really think most of us know the difference.
They're all cyclones. They all have wind systems that rotate in the same direction, but probably the most fundamental difference between them is where they derive their energy from. So tropical cyclones derive their energy from the warm oceans through something we call fluxes. So sensible and latent heat flux, this is moisture and thermal energy, moves from the ocean into the atmosphere. And this then drives the deep thunderstorms that keep the circulation of the tropical cyclone moving. For an extratropical cyclone, these are also known as mid-latitude cyclones. They derive their energy from a completely different source, which is actually from the atmosphere. So in the mid-latitude atmosphere, you have a structure to the winds. Winds are generally much weaker at the surface and much stronger in the upper atmosphere where we tend to find those jet streams. So this changing winds with height provides an energy source that supports the intensification and the maintenance of mid-latitude cyclones. And actually a consequence of that, the two structures of the two types of cyclones are actually quite different. A tropical cyclone has its strongest winds at the surface and they decrease with height. But a mid-latitude cyclone actually has its strongest winds in the upper atmosphere where the jet stream is, and the winds decrease with height to the surface, which doesn't mean they can't still be quite strong, but their weakest winds are actually near the surface. But they still have that cyclonic turning to their winds. And then a subtropical cyclone is actually a hybrid. It's something right in between the two. It derives its energy from both sources.
And so extratropical and subtropical cyclones, can they still have the same amount of destruction as a cyclone can?
They can. So sometimes a tropical cyclone can actually become more intense once it transitions to an extratropical cyclone than it was as a tropical cyclone.
So when, I've seen a tropical cyclone, when it becomes an ex-tropical cyclone, does that mean it's transitioned to an extratropical, or that it's just an old, now somewhat defunct tropical cyclone?
Yeah, the terminology can be quite confusing that the operational centres use.
Yeah.
So if they call it an ex-tropical cyclone, it's usually just a tropical cyclone that has weakened off so far that it no longer deserves the designation of tropical cyclone. So the surface winds have just weakened. Maybe it's gone over land or something like that.
Yeah.
And that's a difference. If it's become an extratropical cyclone, then it's done this transition into the tropics and typically re-intensified into some strong extratropical cyclone.
Okay. Another question that I had, I remember having a conversation with you recently when tropical cyclone Alfred was coming into the Queensland coast here in Australia. This was in early 2025. And you were talking about the core of the cyclones and how, especially in the case of Alfred, it was a bit different, it was half one core and half the other. Can you maybe talk to us about how how that might function in the different types of systems?
Yeah, so when Alfred was deep in the tropics and it was very much a tropical cyclone structure, it had a wind structure that had the maximum winds very close to the eye. So that's where you typically find the strongest winds at the surface is very close to the eye. And then they weaken off with radius from the centre. As Alfred moved south closer to Brisbane, it started to transition into an extratropical cyclone. It very briefly interacted with this mid-latitude atmospheric westerly structure, and that caused its structure to change. And when a tropical cyclone starts to transition, that core of very intense winds near the centre tend to weaken and spread away from the centre. Some of it will actually erode away because you actually get some dry mid-latitude air coming in that kind of kills off the thunderstorms in about half of the cyclone. And in Alfred's case, that occurred, so we ended up seeing quite an asymmetric structure to the clouds. Yeah. And the winds will broaden, and they'll actually broaden over, the strong winds will broaden over a much larger area, but they'll also become quite asymmetric and just be on one side of the cyclone.
I was about to ask, because I noticed with Alfred, and I have seen it with other ex-tropical-ish storms, that it had a massive tail that came down the east coast of Australia. So
that's right.
A tropical cyclone would be much better formed and much more symmetrical, is that
much more symmetric about the centre, whereas Alfred developed that very, very big rain cloud that actually is what impacted the Gold Coast.
Yeah. Yes,
and then it also had most of its winds on the south side as well.
Yeah, okay. That makes more sense. Yeah, that was fascinating to watch. I think it really put, this is a bad pun because we've always had cyclones here, but it really put cyclones again on the map because it was a populated
It was a populated area. Apparently it's affectionately called up there Cyclone Alfie.
Oh, Alfie, okay.
Makes it sound like a cockapoodle.
It does, doesn't it?
I actually know a kid called Alfie.
Do you?
Yeah.
Are they a cyclone or are they very well behaved and calm?
I think they're pretty well behaved. An old friend from Sydney.
Nicely handled there. I'm going to steal another of Sarah's questions because she asked the last one.
Sorry.
Liz, can you tell us about the difference in naming conventions? So we call them cyclones down here in Australia, we call them hurricanes in North America or the North Atlantic, and then typhoons in East Asia. Is that something that you know a bit about? Why do we have these different names for the same or similar processes?
So they're regional names that are given by the regional areas that they're in, but they're all tropical cyclones. So the tropical cyclone is the generic term that is used globally. It's the technical term.
So we're right.
So we're right.
Okay, cool.
No, we're just boring. We didn't come up with our own name.
We didn't. But then you just mentioned that so hurricane comes from a local Caribbean term for weather gods, and typhoon comes from local word typhoon meaning big wind in Asia and the Western North Pacific. And in the Bay of Bengal and the Arabian Sea, around that area, they're just called cyclones, and then they're given levels of severity, including up to very, very extreme super cyclone kind of categories.
Can I ask about like actual names of individual storms.
You can ask whatever you want, Sarah. You're in charge of this initiative.
Am I? Really? I've got
You're the
power?
podcast boss.
I'm a professional now. Every time I say that, I think of like Pinocchio in Shrek when he goes, I'm a real boy now. Anyway, Liz, do you know why we name storms after people? And like how does that convention work? I understand it's likely regional, but how do they kind of program the names?
Tropical cyclones originally, so many decades ago, storm captains would name a big wind that they came across in the ocean maybe after their wife or whoever they were angry with probably at the time, their girlfriend, you know. But that's really, I understand that that's where the convention originally came from, that they were named, they were female names and they were named for their wives or their mistresses or girlfriends or whatever. There wasn't any structure to the naming. It was just kind of a personal thing.
Just to throw away misogyny.
Yes, yeah, just casual, like, oh, she's really annoying me today. TC Sarah.
But eventually the World Meteorological Organization took over that part of tropical cyclone information, if you like. They organised the different regions that we now think of as the regions where tropical cyclones exist. So that, you know, Australia sits within one region of the world for tropical cyclone purposes under the World Meteorological Organization. The North Atlantic sits under another and the Western North Pacific sits under another. And within all of those regions, there are committees from all of the nation states that are impacted by tropical cyclones. And they come together and they put together lists of names derived now equitably and with lots of diversity in them. No longer all just named after women. You know, there are men's names, there are local names, and they're not all. For a while, they were all English. Now they are, you know, definitely taken from the region of interest. And they put together 4 or 5 years worth of lists of names for each region.
So I know that like cyclones in Australia, like they alternate the letter of the alphabet and also male versus female names. But I'm not sure if everyone knows that there was I think he was a PhD student some years ago, and he had a tropical cyclone named after him, TC Lamb.
Why was it named after him?
Pretty sure that's what he was studying, was cyclones or at least storm meteorology or something in that general area. But I'm not sure how he got his name on the list. I would like to get my kids on the list somehow. But I think knowing that they're done now 5 years out, I don't think that'll be possible.
Yeah, usually you have to know the operational forecasters who are involved in putting the list together. There have been definitely examples of kids' names getting onto lists from the National Hurricane Centre, for example.
Okay. If anyone from the Australian Centre is listening, reach out to me. I've got a couple to throw your way.
Sarah, there's a fun fact for you from Zach in the chat.
There is too. In 1975, at the time, only female names were given to cyclones and storms. But during International Women's Year, that was 1975, Australian Science Minister Bill Morrison ordered cyclones to carry both male and female names and bearing the title of devastation. Good. Well, at least equality came eventually. But
that's right. I think at that time they were probably still English names. So it did take a little bit longer for regional diversity to get in there as well.
Yeah.
Decolonise cyclones.
Decolonise cyclones, yeah. Equity for all cyclones.
That should be a Greens policy at the next election. They might do better then.
So many of us have probably heard when there's been a cyclone forecast that there's different ratings. Can you maybe take us through like what the ratings are and as well as whether or not they differ across the different regions where we get these sorts of events?
Yeah, so the ratings or the categories are based on the intensity of the maximum surface winds.
Okay.
And so we start in Australian region, we start at a category 1, which is when a tropical cyclone first becomes strong enough to be named. And that's when it reaches winds of at least 17 metres per second at the surface. And that's a 10-minute mean wind. There's actually a lot of different caveats in here as we go around the different regions. But in Australia and in much of the world, we average our winds over a 10-minute interval, and then that's what we call our surface sustained winds. So category 1 starts at 17 metres per second or 34 knots. And then as the tropical cyclone becomes more intense, it will reach a category 2 and then a category 3, and finally up to a category 5, which is our highest category in the Australian region. In other regions, they also use category systems, but they are different and they are indexed at different points.
Okay. Are they based on wind still, or is it are there other inputs as well?
Yeah, these are all wind categories. only. So it doesn't take into account some of the other hazards associated with cyclones. It only takes into account winds that can be in some places in the world can be relatively easily measured.
Yeah, okay. So you said the categories went from like 1 to 5. Has there ever been a category 6 tropical cyclone anywhere?
So category 6 just doesn't exist.
Okay. So it's just like
category
anything-
5 is the top. It's greater than I can't remember exactly what it is for the Australian region now, but it's category 5 basically is defined as anything greater than.
Okay.
And that's true in any part of the world. So there have been discussions about a category 6 along the way. It comes up every now and again. The original wind category system was derived by a wind engineer and a hurricane forecaster in the US, Saffer and Simpson.
Oh,
and
yes.
just their first name, Bob Simpson and Herb Saffer. That were their names. And they went out and they looked at destruction after landfall of a tropical cyclone, and they categorized the tropical cyclones based on the amount of destruction. And so they had wind measurements that went with that, so they could then categorize. And so they categorized, category 1 as, maybe some palm trees lost their tops, all the way through to category 5, which meant catastrophic destruction. So when you think about it, you've already got a category that defines catastrophic destruction. There's no category 6.
Where do you go from
like
that?
You don't get more catastrophic than catastrophic.
No, it's the end of the spectrum.
What happens when a cyclone makes landfall, particularly a powerful one? What kind of effects do we see and what sort of damage does that do?
So we have 3 main hazards associated with a landfalling tropical cyclone. The first one is the storm surge. So the storm surge is where the very strong winds out to often radii of 300 or 400 kilometres drive the ocean in front of it. So it drives an additional storm surge onto the land. A little bit of that's actually associated with the low pressure in the centre of the hurricane that lifts the ocean surface a little bit, but that's only a small part of the whole storm surge. Most of it is actually wind driven. And if that comes in on a low tide, then we see not so much effect, but if it comes on shore with a high tide, we can see quite inland intrusion of seawater based on that storm surge. The second one are the winds. And with the winds, we see a gradual increase in winds as the tropical cyclone comes closer and closer and closer to the point whereas if you're in the line of the eye, then you're going to get a period of maybe an hour of extremely strong winds, a little bit of a calm period, and then strong winds on the backside. And then over the next several hours, those winds ease off again. And then the third thing is the rain, and you can get very heavy rain in both the rain bands that make landfall ahead of time, and then from that very strong ring of thunderstorms around the eye, that's the eye wall, can drop a lot of very heavy rain in a very short period of time. And that's the freshwater flooding part of it. And that rain can actually continue to impact societies well inland of where the system makes landfall. So once it makes landfall, the winds decrease pretty rapidly. The friction of the land just wears them out, if you like. But the rain can actually continue quite far inland as the thunderstorms can just continue to propagate with the sort of the upper level part of the system. There's actually another type of hazard that's still associated with those that can happen upon landfall, and that is that you can get these tornadic vortices. Think of them as tornadoes, actually embedded with the rain bands and the eye wall as they come on shore. And those will give you very localised instances of extremely strong winds and damage.
Sounds horrendous.
What's that?
So it sounds horrendous.
So, Ian asked about the powerful ones. So, this is what happens with the powerful ones. Yeah.
I'm thinking,
things.
I've got an image of like The Day After Tomorrow, that terrible yet iconic movie, loosely based on, the shutting down of the overturning circulation. But yeah, I swear one of the like advertising images was like this storm with all of these tornadoes coming out of it. And that's exactly now what I'm picturing about a tropical cyclone.
Yeah, that's right.
I think that we should screen that film at the annual workshop, Sarah.
Yes.
Do you want to do that?
It is so old though. Like it's, at least almost 20 years old?
But some people may not have seen it. What we could do is, we could screen it and then we could have a discussion on the scientific merit.
Yes. Well, they did consult with climate and atmospheric scientists for it.
That's what they said
loosely.
for Twister as well. In fact, I know one of the consultants for that particular movie, and it's pretty horrifying when you think about who was their consultant and what they actually did.
Yeah.
I don't think they listened to him very hard.
We got cows.
We got twin tails rotating around each other. Yes.
I love that film.
Don't let actual science get in the way of a good story.
No, that's right.
So in Australia, what are the most destructive and infamous tropical cyclones that we've had?
Well, probably the main one that comes to mind is Tropical Cyclone Tracy, which made this impact on Darwin in 1974, Christmas Eve. And there was just this confluence of factors that came together for that particular cyclone. It had a wobbly track, so the forecasters were having a bit of a hard time to kind of predict its track because it was kind of doing this wobble thing like this. And at any point, they thought that it would be turned back in towards the coast, but where on that wobble was it going to get turned, and how much would that then affect it? And eventually it did. It made that turn, and it still continued to wobble. So there's still this issue around exactly where it was going to make impact. It's also a very small tropical cyclone. We can get a huge range of sizes of tropical cyclones. A lot of them are very average size, around maybe 500 or 600 kilometres across.
Okay.
But Tracy was probably no more than 100 or 200 kilometres across in total.
Little baby
Its
one.
eye was tiny,
Yeah.
and its radius of maximum winds was 50 kilometres across.
Yeah, right. Okay.
And it managed to make a direct impact on Darwin, on the business centre of Darwin. On Christmas Eve, when everyone is off having office parties, no one is listening to the news at all. And so the Bureau of Meteorology at this point is trying to get people to take action, to shut down things, to get, if they have weather shutters, put their weather shutters up, all this sort of thing. Darwin was also not particularly built to withstand a tropical cyclone. And on point of impact, Tracy was a Category 4. So that's...
It was Category 4, okay.
It's not catastrophic quite, but it's very extreme. And so it made this direct landfall Christmas Eve on Darwin, and cut a swathe that was about 50 kilometres wide of destruction, through the city.
So, it just seemed like a whole lot of bad luck that it just wobbled. It was Christmas Eve. No one was listening. No one probably, they weren't because they're out celebrating. And it just wasn't built. Darwin wasn't built to withstand this.
That's right.
So
that's probably that's really our most famous one. We've recently had the 20-year and probably the 30-year anniversary of that particular event. Because it had so much impact. Darwin has been rebuilt since, and it's a lot more cyclone safe now.
So would that have changed building standards and preparedness across Australia, not just in Darwin, do you think?
Well, you'd hope so, wouldn't you?
Yeah.
And there's certainly been, over the years, revisions of building codes.
Yeah.
The question right now is really, are those codes up to date and appropriate for now? Brisbane is probably, I saw some images after Cyclone Alfred that had me thinking, well, you can have those building codes in place and they can be adequate building codes, but if they're not actually adhered to, then they're not worth the paper they're written on.
Yeah.
And I saw an example of a photograph of a damaged building where the roof was gone. Every bit of roof was gone. There was some frames still standing, but it was quite clear that the roof had not been adequately tied down to the frame. They learnt back in 1990 with Hurricane Andrew in Miami, not just building codes, but adherence to those building codes was super important. In those cases, houses, not only were roofs not tied to the frames, but the frames were not tied to the foundation.
What?
And so once you get a building that breaks loose from its foundation, it becomes a projectile, downstream projectile for everything else. So things can be built properly downstream of it, but it's going to take them out because a building is a pretty big projectile.
The mind just baffles though. If there's codes, so stick to them. They're there for a purpose. Yeah.
They are, but it's cheaper not to. And so if they're not being adequately applied and supervised, then problems can happen.
What can individuals do if a tropical cyclone is bearing down on them? I mean, in an ideal world, we'd all have storm shelters or, super secure basements we can go into, but that obviously isn't the case for a lot of people. What's the advice normally like when we're facing something like Alfred or a different tropical cyclone?
And so in areas where tropical cyclones are common, there's usually a lot of infrastructure that you can buy to prepare your house against the oncoming tropical cyclone. And then There are levels of warning that are given out by the Bureau of Meteorology. Going again to the US as an example, if you live in Miami and there's a hurricane warning out for a hurricane coming in to make landfall where your house is located, then you have your shutters that you put up over your windows, and you just have a list, basically a shopping list almost, or a to-do list of the things that you do to prepare your house to the best of its ability to withstand that hurricane. And then if the hurricane is bad enough, then the warnings are put out for you to evacuate. And they have planned evacuation routes. They turn the big interstates into a one-way highway to get people out of areas. So they have all of those plans in place. And, we have that here. In places where tropical cyclones have brushed by or been a little bit more common, further up the coast of Queensland, for example, there have been plans put in place. Whether those plans are still adequate, fit for purpose with our population expansion, remains to be seen. They should be revised, but they do exist. And this is what you should do. You should, 1, make sure you understand what you need to do to prepare your house, and then 2, understand that if you need to evacuate, then you don't sit around and have a hurricane party, you get out.
Was there any discussion about evacuating Brisbane or other areas in that part of Queensland as Alfred was approaching?
I don't think so. I think the understanding was that Alfred would be only a category 1 upon landfall. And so there was no real need to evacuate necessarily. Now, I do believe that people did evacuate out of certainly some flooded areas into school buildings and so on that were made available.
I'm kind of interested to know more about some other tropical cyclones that have hit Australia, like potentially up in Queensland, that have had, really devastating effects or have been high categories. Do you know of any more? Like Tracy is very infamous, but do we have any more that are more recent?
Good question. I can talk about a couple that had mostly flooding effects. Well, so one of them was a category 1 on landfall, but it was a particularly interesting, if you like, tropical cyclone. This was Tropical Cyclone Oswald. I think that was 2013. I should know because I wrote a paper I wrote a paper with someone else. Or someone else wrote a paper with me, I should say. DFA wrote a paper with me on that. But it actually formed in the Gulf of Carpentaria. It made landfall onto the peninsula, and then it proceeded to track down the east coast of Australia just onshore, all the way down past Sydney as an extratropical system. And eventually it moved back off the coast. And it caused 3 major flooding events, one up on the peninsula, Cape York Peninsula, one somewhere around north of Brisbane, and somewhere south of Brisbane, just because of its interactions with basically extratropical flow. So it caused a lot of flooding. But another one was more recent, and that was Tropical Cyclone Debbie.
I remember.
In 2017, and that made landfall near Ellie Beach. And one of the main issues around Debbie was that it rapidly intensified right before landfall. So it was actually category 4 upon landfall, made landfall, caused a lot of wind damage and rain damage, and then proceeded to drop a lot of rain. It just proceeded to come down inland and then it curved back out to the ocean again. But in that time, it flooded Bundaberg and various other areas. There are some quite stunning pictures if you go online to have a look of those regions under a lot of water.
Yeah, right.
Sicko.
I remember one, and it caused a banana shortage everywhere. And I remember bananas being like $14 or $15 a kilo, and not like literally not being able to afford a very basic diet staple. But yeah, that one hit up in North Queensland. I can't remember what it was called, but it was that was quite devastating as well.
Yeah. That'll happen if they come inland. They don't necessarily have to come into actual populated areas to actually impact us, downstream economically.
Yeah.
I mean, banana shortage is terrible for me because I eat a lot of them. But
me too.
But
me too.
An avocado shortage would be really good for the housing market because the millennials would all be then able to get on it. No avocados means you'd be able to have a deposit, and it'd really shake things up. So,
yeah, us millennials, we can't afford our houses because we eat too much avocado toast. Yeah, so Liz, I think a lot of us have seen on like forecast maps, or even, when we've heard about tropical cyclones, that their tracks wobble a lot. And I think you've mentioned that just about Debbie was it Debbie? Yep.
Tracy
sorry. There's so many of them. That there was quite a lot of wobble. Even with Alfred, we saw that, he just kind of stalled offshore before he moved in. What controls the track of a cyclone, and why can it be so difficult to forecast at times?
So the track of a cyclone is affected by several different factors. sort of primary ones are the change in the Coriolis strength as you move away from the equator. So the Coriolis increases in strength as you move away from the equator, and that creates a gradient that the tropical cyclone actually will propagate on. It actually steers it, and that steers it away from the equator and towards the mid-latitudes or the polar regions. On top of that, you have a basic fundamental steering flow that in the tropical regions is from the east to the west, and in the mid-latitudes is from the west to the east. So while the tropical cyclone is in the tropical regions, it will fundamentally move toward the west. Okay. So if it forms in the Coral Sea, it would move towards Australia.
Okay.
If it moves far enough poleward under this other influence of the Coriolis change, then it will start to be picked up by the flow from the west in the mid-latitudes, and that will push it back around. So it will end up doing this big kind of steering thing if it moves far enough poleward. If it doesn't, it'll just keep tracking west and make landfall eventually. But if it moves far enough poleward, then it will be picked up by the westerlies and move back to the east. And those are kind of the two basic patterns. So a straight line sticking pretty close to the tropical regions, or this big curving thing that takes it back out to the east again. And in say our South Pacific region, it would kind of move it back towards South America, for example, or over New Zealand is typically what it does, over New Zealand and then back out towards South America.
Yeah.
But then on top of that, there's a whole bunch of other influences that are sort of smaller scale influences. And one of those can be just asymmetries in the cyclone itself. And those asymmetries can make it wobble. And we saw a little bit of that with Alfred. Alfred became quite asymmetric. And so we started to see some wobbles occurring because of as it tracked back towards Brisbane. We also have some land influence. So once the cyclone starts to get close to land, particularly in Australia, on the east coast there, then the land can actually influence the track as well and cause it to do funky things, little oscillations and other sorts of things like that. In fact, around Australia, we probably have the kind of worst case of lots of funky tracks in the world.
So does that make it harder to forecast where they're going to go?
It does make it harder to forecast, especially when the models are giving them different solutions. It makes it very hard to work out what it's actually going to do.
Yeah, okay. Have we gotten better at that though? Like compared to say when Tracy happened and, in that 50-year time period, have we gotten better in getting the track forecasted correctly?
It has got better.
Okay.
It certainly has got better, but you'd be aware just from the example of Tropical Cyclone Alfred, the Bureau was changing the information it was putting out almost every 6 hours because the models weren't coming on a neat enough solution. They knew within a cone of uncertainty where Alfred was going to make landfall, but Brisbane wanted to know exactly where it was going to make landfall, and that made it very hard for them. They were having to update their forecast very regularly because the solution coming out of the model was changing.
Yeah, I remember the day that it was originally forecast to hit or to make landfall. It was like the sun was shining in Brisbane because there was just that.
It was still 2 days offshore at that point, I think.
That's right. Oh, I'm really enjoying this episode. I'm learning
You're on
lots.
fire today, Sarah. I can't get a word in edgeways. It's great.
Sorry. I've had too much coffee and a good sleep. So.
Perfect. The first time since we started doing the podcast.
You're right. I know. And I didn't have to ask what goes where? How do I do this again? I left this at home. I didn't turn it on. There's no batteries. It just worked.
So, Liz, what's the relationship looking like between climate change and tropical cyclones? Are we seeing some patterns emerge regarding this? Is it too early to say? What's the situation there at the moment?
So it is still early days. There are some patterns that are emerging, at least in the Northern Hemisphere where a lot of the studies have been done. So in the Northern Hemisphere, they've shown that the frequency of tropical cyclones is likely to decrease in different basins.
Good.
So they say the percentage of the most intense ones is likely to increase.
Bad.
Now, when we think about that, we need to realise that if they overall decrease, but the percentage of the larger ones, the most intense ones increase, it doesn't necessarily mean an actual change, right? It's just that the proportion is bigger out of the total.
Because there's less there in the pool to
So we do have to take that with a grain of salt. So maybe they've shifted a little bit in being just a little bit more intense. It looks like they will not only be more rainier, that means they'll drop more rain, but actually it looks like they already are. So we're already seeing over the last 5 years or so, tropical cyclones tending to put a lot more rain on the ground. That can be for a couple of different reasons. They could actually contain more rain and moisture in them that rains out. But the other factor is that globally it looks like the movement of tropical cyclones is slowing down. So their speed of motion is slowing down. And if the cyclone slows down, there's more time over a location for rain to fall. So you just get more accumulation for nothing else changing.
Could that also be due to like the atmosphere being able to hold more moisture because it's warmer as well?
So that's the very initial thing that people think, is that there's this relationship that says for every 1 degree of warming of the atmosphere, we should see a 7% increase in the moisture in the atmosphere, that it can hold that much more moisture, which means there's that much more moisture to rain out. So that could also be one of the factors that's occurring.
This is Zach on his deathbed has inspired that question. I don't know if it's nonsense or not.
The question is, I may ask it in a slightly different way, but the question is, could tropical cyclones develop more rapidly in a warmer world because of more carbon dioxide in the atmosphere? But I don't think that carbon dioxide wouldn't interfere directly. It would be because it creates a warmer atmosphere. So potentially could they form more rapidly?
It's not clear because there's a lot of different factors.
Sorry, I've just noticed in the chat that Zach said that was Ian's question. That Ian
I just wanted him to stand up for himself for once.
Just wanted to make it clear that it wasn't his.
So about leading this team, hey Ian.
A lot of leadership is about throwing people under the bus when and if it suits you. You know,
I'll remember that.
Yep.
Noted. Sorry, Liz. Please go on.
It's complicated, as all things atmosphere is complicated.
Yeah.
Just because the atmosphere is warmer and maybe more moist doesn't necessarily mean that we will get tropical cyclones forming more quickly. You know, too many other things have to come together. The thunderstorms have to be able to form in the first place. Now, we immediately think that a warmer, more humid atmosphere should therefore mean more thunderstorms, but not if the whole atmosphere warms unequally. So it's not just about how warm the atmosphere is or how warm the oceans is. It's about the structure of the temperature in the atmosphere, which dictates whether thunderstorms can form in the first place and then whether tropical cyclones can form. And then the whole tropical circulation, as you mentioned earlier, is slowing down. And so that also affects the ability of the parent systems to be there for tropical cyclones to form in. But what we can say is that there's a lot of simulation studies that have been done, including some of my really great PhD students have done, that have looked at how the structure of the tropical cyclones might change in a future climate. And while they might not form more quickly, it looks like they might be just a little bit more compact in the core, so they might have just a little bit tighter thunderstorm ring around the eye, a little bit more intense thunderstorm ring around the eye, and that means that they can drive more rainfall within the eye. In fact, they're saying, not just from ours, but from a lot of other modelling studies, that it looks like the tropical cyclones within the core are likely to be well exceeding that rain estimation of 7% per 1 degree warming. And that they can be as much as 20% per 1 degree warming of rain. Yeah.
I was going to ask about that because this is obviously not a part of atmospheric science I'm really familiar with, but I have heard other researchers say that when a thunderstorm hits or is being formed, that transfer is more than that average 7%. It's can be double-ish.
Yeah. And no one completely understands why, but this is just what the modelling is showing.
I remember around the time of Tropical Cyclone Alfred, when you were doing some exceptional and wide-reaching media work about this phenomena on behalf of the centre and the community. Some of the questions were about, could a tropical cyclone one day reach as far south as Sydney? And while that might be a little bit far-fetched, are we going to see storm tracks and storm patterns and movements change with a warmer world or with a changing climate?
Yeah, so a lot of the evidence, if you like, from models, again, this is from models, in the future suggest that tropical cyclones will be able to move further poleward. And so in our case, that means tracking south of Brisbane and potentially as far as Sydney. They might not do it as what we'd call, a pure tropical system with that very symmetric structure, but something more like Alfred, where they've started to be a little bit more hybrid in their structure. There's a good chance that they can. In fact, there's some evidence to suggest over the last 20 years they already have started to track a little bit further poleward, not onto the Australian coast, but we can certainly see it in the South Pacific Ocean, that they've tracked a bit further south and impacting New Zealand a little bit more perhaps.
So what would it take then for a storm like Alfred to come 1,000 kilometres further down south? Do we need really hot sea surface temperatures? Do we need the atmosphere to do something funky? Both of those factors, what might it be?
Yeah, kind of both of those factors. Ocean temperatures to be warmer further south.
Yeah.
And not just warmer than normal, which they are right now, but above that threshold that will allow a tropical cyclone to keep maintaining itself. But we also need the atmospheric circulation to be a little bit funky. And that kind of happened with Alfred anyway, right? We had that kind of the mid-latitudes flow extended northward enough to pick up Alfred for a little bit, so it developed that hybrid structure. But then it retreated again to the south and left Alfred alone, which allowed it to kind of steer in on Brisbane. Now, as the tropical circulation expands, we could see more of that mid-latitude flow existing for longer periods of time further south, and that's going to give tropical cyclones the ability to be able to move further poleward, further south, while maintaining more of a tropical cyclone structure. So it needs both pieces, really.
So it's not completely off the cards, but would need a lot for it to happen.
Not completely off the cards.
Coming soon to a southern Australian city near you, future tropical cyclone.
Yay, I can't wait, I say with the utmost sarcasm.
Thanks so much to Liz for joining us for that illuminating whirlwind tour of storms and cyclones. Thank you.
You're very welcome.
And next week, we dive into the chilly waters of the Arctic, which could be without sea ice in the next summer. Sorry, let me start that again. Which could be without sea ice in the summer blah, blah, blah. No, that doesn't work for me. I need to edit that. Hang on.
We have a stutter in there.
This is making for great content.
Next week, we dive into the chilly waters of the Arctic, which could be without sea ice in future years.
You missed summer. After all that.
Next week, we dive into the chilly waters of the Arctic, which could be without summer sea ice in future years. With less sea ice to reflect heat, how much will temperatures change globally?
What will the future of coastal communities look like with rising sea levels, and how will global food systems be affected?
And what happens to our diverse range of wildlife under such conditions?
For the answer to those questions and plenty more, join us for the next episode of Totally Cooked.
And we'll tackle the climate crisis together.